Hi guys, today we're going to talk about dilations, and the I can statements we're working on are I can use a graph to explain a proportional relationship between points and figures, and I can find relationships between lengths and areas of dilated figures. And the first part of this lesson, we're going to look at what a dilation is, we're going to do a couple dilations, but we're going to take some notes as we go along to determine this relationship between lengths and areas of dilated figures. Then we're going to look at a graph and talk about how we use proportional relationships to dilate figures on a coordinate plane where the origin is our central point. So let's first talk about what it means to dilate a figure. When a figure is dilated, it grows or shrinks by a given amount, and the amount that it grows or shrinks by is the scale factor, which we've been working with already in this unit. If it grows, we would call that an enlargement. If it shrinks, we would call that a reduction. So, quite simply, you will be asked to determine if what you have dilated was an enlargement or reduction. And that's simple. If it grows, it's enlargement. If it shrinks, it's a reduction. When you dilate a figure, you really just multiply all sides by the scale factor. So what are you creating? You should be creating similar figures. So, if I wanted to dilate the figure below by a scale factor of 2, that means I would have to multiply the length and the width by 2 and then draw my dilated figure. So, I would take my length 1 times 2, which gives me 2 feet, and my width 2, and multiply that by 2, because that's my scale factor. So that was given, which is how I got the 2, and that gives me 4 feet. So when I redraw my figure, it's 2 feet tall, 4 feet wide. You might notice that the shape did not change, but the size did, because these figures are similar figures. Their corresponding angles are the same, they're all right angles, and the ratio of their corresponding sides create equivalent fractions. So, length to width, if I multiply both of those by my scale factor, which is 2, I get equivalent ratios. So I know that these are similar figures because they have the ratios of their sides are equivalent. So if we were to dilate the figure below by a scale factor of 4, that means I would take the length and multiply it by 4, and the width and multiply that by 4. And I would have a 12 by 12 square. On grid paper, and if I wanted to dilate a figure, let's take this one and dilate it by a scale factor of 2. Well, I would have to know that my length here is 1. So my length of my dilated figure has to be 1 times 2, which is 2. My width is 1. 1 times 2 is 2. So I'm basically taking all sides, and multiplying it by 2. Now, since this is a square, I really only have to do one side. But now let's talk about the perimeter of each figure. Well, to count around here, I'd have 1, 2, 3, 4, perimeter of 4, and this one would be 1, 2, 3, 4, 5, 6, 7, 8. So, the area of this first one is 1, because it's only 1 unit square. And the perimeter would be 4. Now, the area of my second figure is 1, 2, 3, 4. And we already found that our perimeter was 8. You may want to jot down some information on the relationship between the area and perimeter of both of these, because later on in this lesson, you will be asked to describe the relationship between the two. So let's look at this figure and dilate it by a scale factor of 3. Now we find the perimeter and area of each. So I would have to find each length here. And to enlarge the figure, because I'm making it bigger, I would need to take each of these lengths and multiply it by my scale factor of 3. So 2 times 3 is 1, 2, 3, 4, 5, 6. 1 times 3 is 1, 2, 3. 1 times 3 is 3. 1 times 3 is 3. So this is how I'm enlarging my figures. I'm going piece by piece, length by length, and multiplying it by the scale factor. 3 times 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. And 2 times 3 is 6. 1, 2, 3, 4, 5, 6. So you see, each side length has been enlarged by a scale factor of 3. I've multiplied each side length by 3. Now, to find the perimeter of my original figure, I just add them up. 2, 4, 5, 6, 7, and 3 is 10. And the area, 1, 2, 3, 4, 5 units squared. Now, let's look at my enlarged figure. I add up all my sides. 6 and 6 is 12. 15, 18, 21, and 9 is 30 is my perimeter, 30 units. And then 3, 6, 9, plus 1, 2, 3, 4, 5, 6 times 6, 36 plus 9, that would give me an area of 45 units squared. Again, take note of how the area changed when I multiplied by a scale factor of 3 to enlarge my figure. How does the perimeter change? You will be asked to write observations in your summary later on in this lesson. Let's look at one more. If I wanted to dilate this figure by a scale factor of 4, I would simply take each side, and the square, each side has a length of 2. And I would multiply each of those sides by 4. So 2 times 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I've enlarged my square by a scale factor of 4 by multiplying each side by 4. Now, find the area and perimeter of each figure. Well, this one has an area of 4 units squared, 1, 2, 3, 4, and a perimeter of 2, 4, 6, 8 units. My enlarged figure has an area of, 8 by 8, that's 64 units squared, and a perimeter of 32 units. And I can count them if I wanted to. 1, 2, 3, 4. There's 8 on each side, so 8 times 4, 32 units. Let's look at this one, our last one. If I wanted to dilate this figure by a scale factor of 2, notice I've taken each of my sides here. Now don't forget about these little pieces here. They're often forgotten when students are enlarging figures. You need to look at every single side in the original figure in order to enlarge or reduce it by the scale factor. So 3 times 2 is 1, 2, 3, 4, 5, 6. 1 times 2 is 2. Don't forget about this 1. Times 2 is 2. 2 times 2 is 1, 2, 3, 4. 1 times 2 is 2. 4 again here. 2, because 1 times 2 goes out here, and then 2 here. So I've enlarged my figure. And now let's talk about the area and perimeter. The small one, 1, 2, 3, 4, 5, has an area of 5 and a perimeter of 12 units. My enlarged figure has an area, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, area of 20, and perimeter of 24. So let's make some observations now. Let's look back at the last 4 examples. The tables show the area and perimeters that we came up with from the original figure and its dilated figure. In the summary section of your WSQ, write some observations you make about the relationship between the area of the original and the perimeter of the original, or area of the original to the area of the dilated, and the perimeter of the original to the perimeter of the dilated. And I'll give you a hint. you're going to want to take note of the scale factor. Pause the video and write your observations in the summary section of your WSQ. Then hit play and we'll do some practice. Okay. If we wanted to dilate a figure on the coordinate plane, we would, let's look at the rectangle ABCD. And A has the points 2, 2, and it's plotted here. B is 6, 2, C is 6, 4, D is 2, 4. They've all been plotted. And I want to use the origin as the center and use a scale factor of 1/2. Well, because the center of the dilation is the origin, this makes dilations very easy. You simply find the image of each vertex of my dilated figure by multiplying its coordinates by the scale factor, 1/2. So I'm going to take 2 times 1/2 and 2 times 1/2. And this will give me 1, 1, because half of 2 is 1. Now, I've put this little apostrophe up here. Whenever we see apostrophes in math, we would say the word prime. So we take point A and we create A prime by multiplying both of its coordinates by the scale factor. And when we say A prime, that simply means it's been transformed in some way from its original figure. It's not the original. I would do the same thing with B. Take 6, 2, and multiply both of those by 1/2 to get B prime, which is 3, 1. C, 6 fourths, half of 6 is 3. Half of 4 is 2, so C prime is 3, 2. And D, half of 2 is 1. Half of 4 is 2, so D prime is 1, 2. Now all I need to do is plot those points on the coordinate plane. Now look. What do you notice when I draw lines from the origin to each of the original points? You might notice that A and A prime are on the same line. D and D prime are on the same line. C and C prime are on the same line, and B and B prime are on the same line. This is a great way to check whether or not you are correct in your dilations, if the origin is the center of your dilation. Now it's your turn. Determine if A, B, C, and D, A, B, C, D, and A prime, B prime, C prime, D prime are similar figures. Now you're going to have to think back to our previous lesson to answer that question. If they are similar figures, identify the scale factor of the dilation that maps A, B, C, D into A prime, B prime, C prime, D prime. So basically, how do you get from this side to this side? What's the scale factor? So, are they similar? What's the scale factor if they are? And then tell me, is this a reduction or an enlargement? Did we reduce our original figure or did we enlarge it? Pause the video and answer this question in the work section of your WSQ. Then hit play. Okay, let's look at one more problem. List the coordinates P, Q, R, and S in the work section of your WSQ. Then list the coordinates of P prime, Q prime, R prime, and S prime if you would dilate it with the origin as your center with a dilation of 4. We are done with the lesson. You can go back and watch any portion of this video as many times as you need to, or watch the entire video. But don't forget to WSQ in your notes.